All right, guys, this is your lesson on plate boundary types, okay? So the first thing I want you to do is tell me what you already know, kind of get that up at the front of your brain. So I do want you to go ahead and pause this video, and I want you to write and answer these questions. So the first one, it says, what happens where two lithospheric or tectonic plates meet? Remember, we can call them lithospheric plates, we can call them tectonic plates. So we're talking about the exact same thing there. They just have two names, okay? And the second question, it says, what would the surface of Earth look before and after those plates meet? So what could change when those plates meet each other? Think about what things would look different, how things would change, whether there might be natural disasters at places like that. So at those plate boundaries, think about what could happen there. All right, so go ahead and pause the video and write and answer those in your notes, or kind of type them on a Google Doc, however you do that. Okay. All right, now that you've had a chance to pause the video and answer those questions, we're going to talk specifically about what happens at plate boundaries, okay? So it depends on what kind of plates are meeting and how they're meeting, okay? So that first question has a ton of different answers. So that's all in the notes today, and that's kind of a really big question to answer, okay? So there can be natural disasters, there can be earthquakes, volcanoes, things like that. And we'll talk a little bit more about how mountains form and like the way the shape of the surface changes. It's not necessarily just natural disasters that happen at those plate boundaries, okay? And the last one, number two, the second one, what would the surface of Earth look like before and after these things happen? So if we think about a flat place that might have mountains now, there could be a new ocean, there could be a new riverbed, the river can move to different places. Earthquakes can shift the Earth's crust, so it can kind of create mountains and valleys and different shapes to the surface of Earth that weren't there before. So it could be flat, it could be mountains, it could change based on the movement of these plates, okay? So we're going to talk about the boundaries today, and we'll talk about the types of them and why they move. All right. So the first thing we need to talk about is tectonic forces. Now, these forces are created by Earth's mantle. We talked about it in our previous lesson about how the mantle is constantly moving. That convection is making the mantle move. So that's creating these forces underneath Earth. And this is what's moving Earth's plates. Okay. So tension is like pulling on a rubber band. So sometimes that mantle creates tension forces. It's pulling things apart. Sometimes there is a compression force that's pushing those plates together. So it's kind of like squashing a marshmallow. It's pushing things together. It's pressing on them. It's squashing them together. All right. And the last tectonic force is shearing. This would be like sliding the two cookies of an Oreo apart, or rubbing your hands together when you're cold. So shearing is making things slide past each other. They're not moving away from each other, and they're not moving towards each other. They're just kind of sliding past each other. Okay. So those are the three kinds of forces we're going to be talking about. And those forces match with the three kinds of plate boundaries that we are going to talk about, okay? So just a refresher, just to make sure we're on the same page, a plate boundary is where two plates meet each other. So we talked about the crust being broken into plates. So a plate boundary is where those two plates meet each other. It's the line between one plate and the next. And depending on the forces that are acting on these plates, they're going to move different ways. And that tells us what can happen at those kinds of boundaries. So what happens at a plate boundary depends on how it's moving. All right. And any noticeable changes in the landscape are going to take many years for us to see, unless there's a volcanic eruption or an earthquake or some kind of natural disaster. It is going to take a long time for us to see these changes, because the plates only move from about 1 to 10 centimeters a year. So the slowest ones are moving really super slow, and the fastest ones are only moving about 10 centimeters in a year. So that's about 4 inches. Okay. So just like we talked about before, there's three kinds of tectonic forces. So there are three different kinds of plate boundaries. All right. Or three main kinds of plate boundaries. The first one we're going to talk about is divergent plate boundary. This one is caused by tension forces. Remember we said that's like pulling on a rubber band. So these plates are moving away from each other. That mantle convection is making those plates move away from each other. All right. So the plates are moving away from each other, And this typically is found underneath the ocean, but it can still be found on land. All right, and new crust is formed at these types of plate boundaries because the magma from the mantle is being pushed up to the surface, and it's going to harden and cool and create more land or more ocean floor. And if it happens under the ocean, if it's creating more ocean floor, we call it sea floor spreading. So it's spreading out that ocean floor, it's making it bigger, so we have a larger ocean. Okay? And the next kind of boundary is a convergent plate boundary. So this is the opposite of divergent. Divergent is dividing, convergent is coming together. So the convergent boundary is caused by those compression forces. Those plates are coming closer to each other, they're pushing on each other, they're squashing each other, so they're sliding into one another. All right? Now, at these types of boundaries, Earth crust is shrinking, okay? So it's getting shorter. It's kind of like that marshmallow. If you squash the marshmallow, it's going to get smaller in that one direction. Now, that doesn't mean Earth is shrinking because we just talked about the divergent boundary creating new crust, okay? So there are places where Earth's crust is being created and where it's being destroyed, and this is where it would be considered being destroyed. It's shrinking, it's getting smaller, so we're getting less Earth's crust at this area. Now, what happens next depends on the kinds of plates that are meeting. So this one's got a whole bunch of different things that could happen because if it's a different kind of plate, then different things are going to happen. If it's an oceanic plate and a continental plate, so underneath the ocean and one of the continents, if those are meeting, the oceanic plate is going to go underneath the continental plate and be melted into the mantle, and we call that a subduction zone. The ocean's crust is being subducted underneath that continent, so the oceanic crust is being destroyed, and the continental plate is just kind of sitting there letting that happen, okay? All right, and if two oceanic plates meet, one is going to sink underneath the other, and then you're going to have some volcanoes form there. Because since those plates are very similar in their density, one of them will sink under the other, but the other one is going to be kind of squashed together, and you're still going to have some thinner areas in that piece, so you're going to have some volcanoes that form. All right? And if it's two continental plates, they are going to push up on each other. They're going to kind of squash each other a little bit. And if we think about the marshmallow again, if you push on that marshmallow, it's going to get shorter, but it's also going to get a little bit taller. If you think about it that way, if you're squashing the marshmallow from end to end, then your marshmallow is going to get a little bit taller as you squash it between your hands. So the same way, when those plates meet each other, when they start pushing on each other, they're going to get thicker and it's going to push up into mountains. So a lot of mountain ranges are formed at convergent boundaries. All right, and our last type of boundary, our third type, is a transform boundary, and this is caused by those shearing forces. So we talked about the shearing forces as kind of like sliding our hands against each other to keep warm and kind of sliding those cookies of an Oreo apart. So we're pushing on those cookies on the Oreo and we're sliding those off of each other, trying to keep the cream in the middle. All right. So a transform boundary is where those two plates are sliding past each other. And at this boundary, Earth's crust is neither created or destroyed at this type of boundary. Now, that's not saying that things don't get messed up at this plate boundary. It's just saying that we're not creating a whole bunch of Earth's crust and we're not destroying a whole bunch of Earth's crust. So we are going to have a lot of earthquakes at this type of boundary. It's going to be a ton of them. So there can be damage at this plate boundary, but we're not creating a whole lot of Earth's crust and we're not destroying a whole lot of Earth's crust, okay? So those are our three main boundary types, and your activity that goes along with this lesson is a simulation of each of these types of boundaries. So you're going to get to see this in motion. You're going to get to see what happens. You're going to get to see these changes over an extended period of time when we use that lab.